And a big g'day to everyone down there at Heywood. It's Graeme Anderson here from Agriculture Victoria with a bit of a climate update for your part of the world. And Agriculture Victoria puts out the break newsletter, and you've got Milking the Weather, but this is just providing updates on seasonal forecasts and commentary. Plus we monitor soil moisture conditions with deep soil moisture probes, so all useful tools for helping understand seasonal risk. So here's a great tool I just want to share with you. It's the Climate app. You can download it onto your phone, or you can look at it from your desktop from Climate app. But you can basically see all of these sites here. There's heaps of different rainfall sites down here, and you can download them. And I've downloaded Heywood Post Office, and you can do things like tracking how's rainfall gone for last year and this year. So you can see starting at January last year, you had a pretty good year. You got a lot more of a spring than anyone else did, or at least a winter anyway. And but it looks like it's been a pretty dry summer there. Also, with that little tool, you can do things like just ask queries. It's always a good place to start. What's happened in the past? So here was just an example. How often? We say, how often do we get more than 50 mil? So 2 inches in the old scale in a fortnight. And from 1st of March to 30th of April, and you plug that in and it tells you how often that's happened in the past. So that's happened almost 50% of the time. So down your way, but perhaps a bit less often in the last 20 years. Here's a long-term rainfall record for Heywood, goes back to 1887. You can see here. And this is sort of the long-term average, which is 816 millimetres. That's the average for the long term. And you can see some years it's over 1200 millimetres, and some years it barely gets to 600. So a lot of variability there. You might want to pause on that and have a bit of a look at it. But basically, we'll talk about what's behind some of those wetter years and dry years, but also note that probably in the last 20 years, you've had more than your fair share of dry years. And this is that same record here with summer, autumn, winter and spring, and you can sort of see pretty strongly sort of winter and spring dominated. A lot of variability there through summer. Autumn has certainly been in the last 20 years there. The last few years probably not been too bad, but certainly not too many wet autumns there in the last 20 years. Winter's sort of looking all right, and spring's probably been giving a few more problems there in the last few years. So that's something to watch. We're going to just talk about where does all our moisture come from those wetter and dry years. And this is basically a map of precipitable water. So it's sort of measuring kilograms of water per cubic metre of the atmosphere. So you can see that really most of the moisture is generated along the tropics where the oceans are warmest. And those wetter years are when we're getting extra moisture feeding into our weather patterns down here. And a key driver for those is things like the El Nino Southern Oscillation. It blows trade winds towards Australia, sometimes all the warm oceans up here and all the extra cloud, and when that's there, that feeds into our weather patterns down here. Same with the Indian Ocean Dipole in 2016. It was in its wetter phase, sent heaps of moisture down, and when that moisture being fed in up here hits this colder air, you can see all these cold fronts that whiz around the Southern Ocean, and as they go over Heywood, it's those wetter years are when we've got a good flow of moisture over our heads, and it crashes into that colder air down south. So that's important. The Indian Ocean Dipole went into its drier phase there last spring, so that was not helpful. And but basically, wetter years are when these two are on their wetter phase, and dry years are when they're not sending us much moisture. The seasonal forecasters look at these a lot. This is sea surface temperature anomaly map. So this is just measuring where sea surface temperatures are either warmer or cooler than it is normally. So overall the water's a lot warmer at the equator than it is down south, but this is just looking at the difference compared to normal. This is what a dry pattern looks like, looking at spring 2006, El Nino in the Pacific, extra heat in the ocean there, extra cloud, and all of the extra moistures over in this part of the Pacific. And you can see here cooler oceans, would have been a lot of blue skies in New Guinea and less moisture to feed into our weather patterns in those sort of years. Keep a look at this area in the next slide will just show you what happens with a wetter pattern. So we'll go to, say, spring of 2010. So here we go. There's that big difference, big La Nina, October 2010, big La Nina. All the warmest sea surface temperature was in our part of the world, heaps of moisture blowing in, and really then it was just a matter of who it was going to fall out on. But anyway, that's what the seasonal forecasters look at to try and work out, whether we're in for a wetter or drier sort of season ahead. Now, I'm just going to look at that Heywood rainfall record, and when we go through the long-term history, the 30 years is sort of dry, a third are wet, and a third are average. And we're going to look to see if there's any difference in El Nino or Indian Ocean Dipole years in that Heywood record. So for that Heywood record, we're looking here at August to November rainfall. There's been 30 El Nino events in that record, and rather than a third of them being in decile 1 to 3, it's more like 60% were decile 1 to 3. You can see that El Nino doesn't guarantee dry, because there's still been a few that were average or wetter, but it's certainly, if you're hearing about an El Nino, it sort of doubles the chance of a dry spring. Same too, just like last year we had a positive IOD, dry year. In that Heywood record, there you can see that tends to increase the chance of those drier August, November periods. Doesn't guarantee it though. La Nina years, when there's extra moisture, you can see the fingerprints there for those bit better springs, and the IOD negative, like 2016, when it's sending more moisture, Indian Ocean Dipole, then it, 2 out of 3 of those were in, decile 8, 9, 10. And there's probably one that was dry. So it's a pretty strong driver for your part of the world. So that's just a quick rundown of variability. Is there anything different going on than just good old-fashioned variability? Okay, well here's a bit of a difference. You can see here, this is the temperature story for the last 100 years for southeastern Australia. This is from the Bureau. You can see summer, autumn, winter and spring. And you can just see there we've been just through our hottest summer on record, and I think Victoria was almost sort of 5 degrees warmer than average, so pretty hot. Increased chance of sort of warmer years in the last decade or so. And one thing just to keep an eye on there is spring is one of our fastest warming seasons. You can see over the last 10 years we've had a number of springs between 1, 2 and almost 3 degrees warmer than average, and that's just basically summer getting bigger. So that's part of a trend that they expect to continue, and one of those things down now. The bit of milder sort of winters, probably pretty good for pasture growth and things down your way, but it's probably more the issue of having this sort of bigger summer that extends a bit into autumn and spring to have to contend with. And here's just spring maximum temperatures for down there at the Mount Gambier site. So you can see there at that local record there. So what else is a bit different? This is work by David Stevens from Western Australia. It looked at up to the year 2000, the previous 100 years rainfall, and when it fell throughout the year in terms of winter dominant rainfall zones, which are down south, summer dominant rainfall zones up north, and where it's uniform throughout the year. When he looked at how the rain's fallen in the last sort of 16 years, basically showed that seasonality had shifted south. So there's a bit more of that uniform rain throughout the year sort of pattern had shifted well into Victoria from where it once was. So that's one bit. You're still clearly in the winter dominant zone, but that's probably what's been expected with shifts in climate, that climate zones shift south. Another thing with climate and changing, there's just a bit of work going on which is looking at storm dynamics, and basically when you warm the atmosphere up, you can tend to have bigger cloud bursts and more intense rain. So that's certainly one thing that a lot of farmers are noticing too. And another thing that's a bit different, this area over southern Australia, you can see here they've looked at the pressure pattern, and this is since 1950 through to say 2016, but you can see variability there from year to year, but there's a trend there where the pressure pattern over this region, which includes us, is getting stronger over time. So that's to do with climate change, and that's what's probably to blame for those sort of drier autumns and things you've had down there at Heywood. One of the things about this too is that not only does it squeeze out the odd rain event, it also, if the pressure pattern's still in the right spot, it can really still drag in some really cold dry air, which can still give us a bit of frost risk. So I've got a few forecast tools going to run through here. Here's some which they'll probably show you in the workshop, but I like this one, the chart view of the Bureau. You just hit play and watch the weather access weather model run for the next 7 days. There's this one, the 4 and 8 day rainfall. The wattle forecast is really good, and Med-Eye's another useful tool. Important thing too, increasingly, and this is just an example of one weather event, and this is the Bureau's access model, but here's the European model and here's the US GFS model. Now a lot of farmers have got different apps and forecasts that they're using, but unless you know which forecast model the app is using, they could be providing different things, and so no one can predict the future perfectly. So it's interesting just to at least make sure you know which model your forecast is coming from, and it's useful to actually compare models too, because the more the models agree, then the more you can bank on that rain. I like this one, the wattle site that the Bureau's got. Why I like it, it's got the sort of 1, 2 and 4 and up to 8 days rainfall, but it puts together the forecasts of 6 different leading forecasts in the one bit, so it's a pretty good guide to go on. It works really well. It just probably doesn't work if it's thunderstormy conditions, because it's they can't really tell. There's a lot of variation that happens with who gets rain and who misses out in thunderstorms, but for the more wider rain events, this is a really good site. Another thing just want to talk about, a lot of farmers really ask, what's going on with some of these forecasts, especially with the seasonal forecast for the next 3 months. And this is an example of one from the Bureau. And one of the key things when we get a weather forecast, they sort of tell you what they think is going to happen. But once you move beyond the week, they move into what's called probabilistic forecasts, where they give you probabilities. And you might remember this. This is, say, from September last year. When you see these sort of 3-month forecasts, and they're showing that, well, this sort of colour is showing that there's a chance of exceeding median rainfall, only a 30% chance of exceeding the median rainfall. Now that's the same as 70% chance of drier or 30% chance of wetter. And what it sort of means there is they've run the model, the climate model's probably 100 times. It's had 100 runs, and out of the 100 runs, 30 of them have ended up being wetter, but the majority of them, 70, have been drier. So it's just important to recognise that this doesn't guarantee that it's going to be dry. It's just saying that the odds are skewed one way or another. Now the good news is there's some improved ways of communicating this, that you'll see some new products coming up in the next 12 months. And this is one of them, where they've got things like, rather than just wetter or drier than average, they might have a product such as, here's decile 1, 2, decile 3, 4, decile 5, 6, decile 7, 8, and decile 9, 10, which is the wettest 20% of years. But the forecast, if they run the model 100 times, this might be the sort of product that they get, where they said, well, only 8 of the models came on that wet decile 9, 10, and 33 of the models were on decile 1 and 2. But it shows at least that all of those options are there. It's just skewed to one end or the other. And I think it's probably a more accurate way of explaining it. So in addition to the map. So that's not the current forecast, that's just an example. So hope you will see a few more of these in the next year or two. Here's an example of one from the end of February, just showing this for, say, Ararat, and you can see this is the map product, which is sort of saying slightly increased chance of drier. But when you look at the spread of those model runs, so out of 100 model runs, say for Ararat in this instance, 30 might have been on decile 1, 2, but you can just still see there are other options there. So it means you really still got to plan for anything. It's just saying that, well, perhaps there's a little bit more chance, and there's, instead of a 20% chance of decile 9, 10, they're saying we've only got half the chance of that. So 10 of the 100 models still had a wet event in there, but more of them were skewed to this dry bit. So that's just one way of trying to help explain these probabilities, because it can be a bit tricky to use. So yeah, look out for some new products that are going to be coming from industry groups that are working with Bureau to improve these forecasts. And the Break newsletter puts this out. Dale Gray puts this together. He does a scan of 12 different global seasonal outlook models and looks at Victoria on each of those models and puts it into this chart here in the fast break. So this is the European model. This is the Access Bureau's model. That's Japanese. There's a couple from US, China, UK. And basically this is their February run of the models for March, April, May. And this is what they're thinking about the Pacific Ocean. This is what they're thinking about the Indian Ocean. And what they're thinking about rainfall for Victoria. So he runs through all of them, and you can sort of see that most of them in this little, he summarised them here, most of them are sitting on average. There's one that's on wetter and 4 that are on drier. Most of them are on warmer for the next 3 months. Now this is a pretty good guide, and so anything can happen there at the minute, but usually when we see more than half of them start to light up with either drier or wetter, then that's when we certainly start to take more notice and have more confidence in the forecast outlook. Also, how these forecasts change from month to month can be really useful. So at the moment, there's a lot of just sort of watching in the Pacific to see if an El Nino might form later in the year or not. So it's still early days, and autumn's a really wishy-washy time where the oceans are still setting up. So we've got to plan for anything. So with a lot of the climate variability that we're seeing around the place and mixed in with a bit of climate change, there's a lot of things that agriculture is doing to improve their lot with new technologies and R&D and improved genetics. So lots happening, and when we get decent seasons, it's amazing how much we can produce. But a lot of farmers are still dealing with, if you have a good season, it's not long before you're dealing with another bobtail spring or something like that. And I guess these are the things that farmers are doing to deal with that. So improve farm infrastructure for water and fodder, really important. Also important to have that so that there's improved regional infrastructure as well. Importance to be making sure we're keeping up with local and domestic markets, and business management for variable years and incomes becomes increasingly more important. Farm plans, having good soil cover, especially when we've got either really wet or really dry years, is really critical, because most of the damage to our soils is done when we're at the extreme ends of the weather. And this is really good stuff for just around making sure you're networking with others and good knowledge channels to keep up with the latest and what's going on. So good luck with your workshop, and hope that's been of use. So if you want to subscribe to the break, just drop us an email, and hopefully Michelle will show you some other links there of some of those climate tools so you can have a look at. Okay, all the best.